So today we're going to talk about stoichiometry. Stoichiometry involves how chemicals combine in reactions, everything going on with the amounts and whatnot. So you can think about this if you're putting together a Lego car. If this car here, if this car here requires a body and a yellow brick to be put on that body, and then two fenders, and then four tires to be put on the axles, and that's the car, it should make sense to you that you could figure out stuff like what happens if you have, say, 32 tires. And if you have 32 tires, how many cars can you make, right? How much product can you make? Well, there's four tires for every one car, right? This isn't rocket science. And so, therefore, that gives you eight cars, four into 32. You can make eight cars if you had 32 tires. All right. So that's not unlike a chemical reaction where knowing how many of these things you have helps you figure out how many products you make. Now, let's say you're in a situation where you have a lot of tires, like here, right? So you have a situation like up here where there's a whole lot of tires and you don't want to count those. So you just weigh them. And it turns out that you weigh them and you get 39.1 grams of tires. Now, does that mean you can't do this? No, that doesn't mean you can't do this. You can still do this. What you need then is to know how much a tire weighs, right? And if one tire weighs 0.71 grams, then you should be able to get from 39.1 grams of tires all the way to cars. But in this case, you're going to first figure out how many tires you have. And to do that, you're going to cancel grams of tires using this thing that you know right here. There's 0.71 grams of tires for every one tire. All right. So that gets you out of grams. And then if you want to get from tires to cars, you also know there's four tires in every one car. So just like we've been doing before, you're using the units to determine how to get to where you need to go. And so in this case, you would get 13.7 cars. Obviously, you can't have zero point 0.7 cars. One car wouldn't have enough wheels. So in this case, it's really just 13. But in chemistry terms, we'll always have, we'll be able to use decimals and whatnot. All right. So you get 13 cars out of that many tires. It's a matter of just knowing the grams per tire that you need. All right. So here's stoichiometry. Instead of making cars, we're making aluminum oxide. And instead of having tires and axles and fenders and whatnot, we have aluminum and oxygen. So we're going to do just like we've been doing with the past. You're going to start with your given and go to what's needed. So if you ever need a mole to mole relationship, a relationship between one mole and another mole, you're going to look to the the balanced equation. And the balanced equation is telling you, just like with the cars, right? Just like here, that you needed four tires for one car. Here, it's telling you you need four aluminums for two aluminum oxides or three oxygens for two aluminum oxides. So that's what the balanced equation tells us. Grams to moles, you should remember this from my song before, that comes from the periodic table. Yeah, we're going to keep it in green, I guess. Oops. All right, so the periodic table turns grams into moles, and the periodic table turns moles into grams. All right, so given 9 moles of oxygen, our given is 9 moles of oxygen. That's the number that's provided. What do we need? Where are we headed? We're headed toward moles of aluminum. So we want moles of Al. So we're going to start with what's given, the 9 moles of oxygen. All right. and we're going to convert moles of oxygen to moles of aluminum. Well, mole to mole comes from the balanced equation. So I need this 3 for the oxygen, and I need this 2, or I'm sorry, 4 for the aluminum, because that's where I'm going. And that's it. Moles cancels. Moles is what I was needed, so I'm stopped right there, and I get 12, right? So 3 into 9 is 3, 3 times 4 is 12. So that's 12 moles of aluminum. Done and done. Okay, same situation, same balanced equation, but now we're looking for grams. And since we're looking for grams, we got more going on. Okay, so this was nice, easy, easy, just like the first thing here. This was nice, easy, easy. We wanted amounts. We started with the amount of tires, 4 tires in every car. Now we need grams, just like we did here. Now we have grams. Grams is going to make this a longer process. So if we're going to need grams, so we're given 9 grams of oxygen, right? That's what our given is. And our needed is grams of aluminum. So we're going to start our scaffolding with what's given, the 9 grams of oxygen. And we got to get rid of grams of oxygen and get to moles, because moles of oxygen is what we're going to need to get us through, right? Just like with the car, we needed the amount of tires to get us to figure out how many cars. We need to know the amount of oxygen to get us to figure out how much aluminum we're going to need. So this comes from the periodic table. This relationship comes from the periodic table. Grams to moles. We're trying to find grams to moles. So the periodic table will tell you that oxygen has a mass of 16, right? So it'll basically be something like that. And since we want 2 of them, O2 equals 32 grams in 1 mole. All right, so then we need to go from moles of oxygen, we got to get rid of that, to we want grams of aluminum, but we can't make that jump yet until we go to moles of aluminum. So we need to use this balanced equation. And every single one of these questions will require that you use the balanced equation. So we want to go from 3 moles of oxygen to 4 moles of aluminum. We got this from the balanced equation. All right. And then we got to get to grams of aluminum. So we got to get rid of moles. Oops. Got to get rid of moles of aluminum. And we got to go to grams of aluminum. And if we're going to do that, we are going to need grams to moles, the periodic table. So we're going to go to the periodic table, and aluminum is going to be 27.0 grams in 1 mole. And there you have it. So when you multiply 9 times 1 times 4 times 27 and divide it by 32 and divide it by 3, you're going to get 10.1 grams of aluminum. So these problems look the same. One was a lot easier than the other because this one didn't involve grams, it just involved moles. And this one did involve grams, right? No grams, pretty easy. Grams, had to keep going to that periodic table. All right. So basically, in our stoichiometry highway, if you have to start here at grams, then you got to use that periodic table. Then you got to use the balanced equation. Then you got to use the periodic table again if it asks you to go to grams. If all you need is moles to moles, you just use the balanced equation. So if you're starting here, then you just need the balanced equation. You don't need the periodic table. And if you're ending here, then you just needed the balanced equation. That was the first instance. We went moles to moles. Moles to moles just required balanced equation. Grams to grams, grams to grams required we use the periodic table, we use the balanced equation, we use the periodic table again to come out this side. All right. So now there's also the possibility I'll start you at grams and ask you to stop at moles. So then you only need the periodic table once. Or I'll start you at moles and ask you to end at grams. Then you only need to use the periodic table once. So it depends where you're starting and where you're getting off this highway. If you get on here, you need periodic table, you need balanced equation. And then if you are going to keep going, you need periodic table again. If you're getting off, then you don't need the periodic table again. All right, so let's try this one. 5 moles of aluminum oxide. So let's change our color. Guess we'll go purple. 5 moles of aluminum oxide is what's given. And we're trying to get to moles of aluminum. So if we're trying to get here and we're starting here, let's look at our highway. So according to our highway, we're starting at moles and we're ending at moles. So we're starting at moles of one and we're trying to end at moles of the other. So that's going to require we just use the balanced equation. That's all we need for this one. So we're going to start with our 5 moles of Al2O3. And we're going to need that balanced equation. We're going to need this, the 2 moles of Al2O3. And then we're going to need this, the 4 moles of aluminum. Then 5 divided by 2 times 4 is going to give us 10 moles of aluminum. Easy peasy, right? Guess what the next one's going to do? Look at the difference between this one and that one. We've changed word moles to grams. Now we're looking for grams, right? And we're looking to find grams, and we're starting at grams. Otherwise, very similar situation. But this is going to require that we start our highway here, right? Now we're going to start way over here, and we're going to need the periodic table once, the balanced equation, periodic table, and then that'll take us out to here. So we got more steps here. So we're going to start with 5 grams of aluminum oxide. So we got the 5 grams of aluminum oxide, and we're trying to go to grams of aluminum. And in order for that to happen, we're going to use that periodic table. So let's start with our 5 grams of aluminum oxide. And when we go to the periodic table, aluminum, there are 2 atoms, and each one weighs 27. And oxygen, there are 3 atoms, and each one weighs 16. So 2 times 27 gives us 54. And 3 times 16 gives us 48. So this is a grand total of 102 grams per mole of aluminum oxide. So we want that grams, the 102 grams on the bottom, and we want the 1 mole on the top. All right, now we're out of grams. Once we're out of grams, we got to go to that balanced equation. Let's go to the balanced equation. We need for every 2 moles of Al2O3, we need 4 moles of aluminum. Balanced equation's been used, but we still got to keep going to grams. So if we're going to keep going to grams, we need to again go to the periodic table. And 1 mole of aluminum on the periodic table is 27.0 grams. So we do all that math and we get 5 times 4 times 27 is 540. And then 102 times 2 is 204. And when you divide 540 by 204, you get 2.65 grams of aluminum. All right. So there you have it. Um, this next one, new reaction. Okay, new balanced equation. We're going to start with 6.7 moles of propane. That's this stuff. So we're going to start with moles. And we're going to go to, now we need moles of water. So this is a mole to mole thing. So on our highway, looking at this, we're just going moles to moles. So we're just going to need, we're starting at moles of propane and we're going to change it into moles of water. So we just need the balanced equation for this one. All right. So we're going to start with our 6.70 moles C3H8. And then our balanced equation says for every 1 mole of C3H8, there are 4 moles of water. And that's that. That's all we need. So that gives us a grand total of 26.8 moles. All right. So now we're going to do it again. Look what we're doing. What words are changing? We've changed the word moles to grams. So this is going to be a lot harder now. So we're going to start with 6.70 grams of C3H8. And we're going to go to grams of water. So on our highway, starting here, going through the periodic table, through the balanced equation, through the periodic table, and coming out there. All right. So 6.70 grams of C3H8 is a good starting place. We want grams to moles. Grams to moles we get from the periodic table. So we need C3H8 is carbon. There's 3 atoms, each one weighs 12. And then hydrogen, there's 8 atoms, each one weighs 1, for a grand total of 44 grams. So that's 44 grams and 1 mole of C3H8. Now we need to go to water. So we're going to need that balanced equation. All right. So we're going to need, for every 1 mole of C3H8, we need 4 moles of water. But we got to keep going to grams. So we've used the balanced equation. Now we got to go to the periodic table. And for every 1 mole of water on the periodic table, hydrogen is 1, oxygen is 16. There's 2 of these. So that's a total of 18 grams, right? So that's 18 grams of water for every 1 mole. So that gives us, when everything is multiplied, 6.7 times 1 times 4 times 18 divided by 44 gives us a grand total of, rounded to significant digits, 11.0 grams of water. All right.